Okay, this one is less practical, but we still have to talk about this because it's extremely important. We need to talk about codecs, what they mean and how they impact our edit workflow. A codec is a method of encoding data into a file that stores a video stream. There's also a corresponding method of decoding that file so that it can be played back on a display device. The footage file itself is not like a sequence of images. It's a set of information that has to be decoded by your machine before that image makes sense. There are many ways of encoding and decoding images, and they all have different intended uses. We are going to talk about three main codecs in this lecture. First, we're going to talk about H.264 and H.265. You're probably familiar with these already if you've done anything in video before. Many phones and DSLR cameras capture footage in H.264. It is a very lossy method of encoding that doesn't actually hold that much information when compared to other codecs. It's also surprisingly demanding for our machines to decode and play back. The idea is that it makes the best use of the available storage space, but that means there's a lot of work in decoding the image back into something that makes sense. You may have noticed that the files we've been working with so far have been playing back slowly. This is because H.264 places a heavy demand on the processor in order to decode. Depending on your workstation or laptop, you may find that it slows down very quickly and that is really frustrating. We're going to go over how to fix this in the next lecture. For now, just know that H.264 is not actually a good format to work in at all. I have only given H.264 files to you because they make for the smallest downloads on your end. One last thing to note is that H.264 will play back even more slowly if you play it backwards. This is down to something called long GOP encoding, which you don't need to understand just now. The usual use for H.264 is final delivery to something like YouTube or Vimeo, or for posting online. It's also a good codec to use for sending work to clients and directors for review, because it can be sent online relatively quickly, and that, of course, depends on your online connection. Second is ProRes. This is Apple's codec, and it's what is known as an intermediary or mezzanine codec. ProRes actually stores a lot of information and is surprisingly easy to decode. In fact, it'll likely play back quicker than H.264 in a lot of cases. We use ProRes as a working codec, and then there are a few different variants that are used for different reasons. We often transcode or export a clip in another codec for a variety of reasons. We export footage to ProRes 422HQ or 4444 for use in the grade or in After Effects, for example, if we are using a kind of independent workflow. If you're working on a Mac, then you will use ProRes 422LT in the next lecture to make the H.264 material I've provided play back more smoothly if you are having problems. ProRes codecs cannot be exported on a Windows workstation unless you're working in the Adobe suite. And finally, we have the DNX codecs. Now, these are the Avid codecs, and they were developed by Avid for use as intermediary codecs and actually predate Apple ProRes. The DNX codecs serve the exact same function as Apple ProRes, but are also available on Windows outside of Adobe. DNX has a number of variations to use as well, and if you're on Windows, you'll be using DNX HR low bandwidth LB variant, which is comparable to ProRes 422 LT. Once we're finished working with our intermediary codecs, we then export to H.264 if we're uploading to web, or a few other formats depending on our delivery destination. This will be covered later. This has been a good overview of the concept of a video codec. In the next lecture, we're going to put this into practice by optimizing our footage to play back better in Resolve. So click on through to the next lecture.